Okay, so in this video, we're going to look at inverse elements. So you might want to pause the video and just have a read of the definition. Okay, so if for an element A in the set S, there exists an element B also in the set S, such that if we do B combined with A or A combined with B, okay, and the result comes out as E, which is the identity, then we can say that B is the inverse of A, and actually we can also say A is the inverse of B. Okay, so what you're looking for, if you're trying to find the inverse of an element, okay, you're looking for the element that you can combine that element with in order to get the identity. Okay, we can use the Cayley table to help with this. Now, just some notation, the inverse of A is often denoted A to the -1. So the -1 isn't a power in the sense that it's not equal to 1 over A. Okay, however, it's just the notation we use for inverses. So you should have used it at GCSE for inverse functions, for example. So if we have a look at this scenario here, okay, so we need to find the inverse of each element for the operation of multiplication modulo 5 on the set, and it should say 1, 2, 3, 4, not 0, and that should be there. Now, we already did the Cayley table for this operation in a previous video, and also we established that the identity E was 1. Okay, so if you don't know how to get that, maybe go back and watch that video. Now we're going to try and write out the inverses of all the elements. So we need the inverse of 1, the inverse of 2, the inverse of 3, and the inverse of 4. So let's start with 3. Okay, so to find the inverse, go to the row with 3 in it. So that would be this row here. Okay, or you could do column and look across that row and try and identify the identity element. Okay, the identity element is here. Okay, and it's in the column with 2. Therefore, the inverse of 3 would be 2. Okay, and this is why you need to find the identity first in order to be able to find the inverses. Now, let's do the inverse of 2. So if we go to the row with 2 in it, okay, and if we look across that row, where's the 1? It's here. It's in the column with 3. So therefore, the inverse of 2 is 3. And that checks out with what I said earlier about how if one element is the inverse of the other, then the other one is the inverse of the other. Okay, so once I sort of knew the inverse of 3 was 2, I didn't really need to check the inverse of 2. I knew what it was going to be. Okay, let's do 4 next. So that's down here. Okay, so if we look in the row for 4, the identity 1 appears at the end. Okay, and that is in the column with 4. Okay, so therefore the inverse of 4 is 4. So we would say that 4 is a self-inverse element. Okay, finally we're going to do 1. So the inverse of 1, the row with 1 is at the top here. If we look across this row, where does the identity 1 appear? Right at the start, and that's in the column with 1. So 1 is also a self-inverse, and actually the identity will always be self-inverse. Okay, because if you do the identity combined with the identity, the result should also be the identity. So I didn't really need to check the Cayley table for that one necessarily.